The last and final form of kinetic energy that we will talk about is thermal or heat energy. Some questions I pose to you is, how is heat transferred? Is heat transferred from hot to cold or cold to hot? What force can cause heat to build up? How can heat cause matter to change from a solid to a liquid to a gas and back and forth? Heat is also known as thermal energy. Thermal energy is the energy due to the motion or collision of atoms. The transfer of thermal energy is called heat. Heat energy can be produced by a force that we have already talked about called friction. Remember, friction opposes motion. Just like in a running car, we use motor oil to fight friction. However, your engine will get hot. Heat energy causes changes in temperature and phase of any form of matter. Geothermal energy is an example of thermal energy. So the other question I posed was, is heat transferred from hot to cold or cold to hot? Well, most students think when I put ice in a cup of Coke that the ice cools down the Coke, so students think that heat is transferred from the ice to the Coke and cools it off. However, heat is transferred, if you look at this picture, from hot to cold. Basically, heat is leaving the Coke, causing the ice to melt, which is changing its state of matter. And when the heat leaves the Coke, then the Coke actually gets colder. It is the same way your air conditioner works in your car or in your house. So on to your Frayer model notes. Again, the definition of thermal energy is caused by the motion and collision of atoms or particles of matter. These movements and collisions, no matter how tiny they are, cause friction, which in turn produces heat. Thermal energy is heat energy. Friction causes that heat to build up. Heat is transferred from hot to cold. Say it with me. Heat is transferred from hot to cold. Think about your body and the vocabulary word you learned last year called homeostasis. Your body is constantly moving, and that movement creates heat, which allows you to maintain a constant temperature of 98.6 degrees Fahrenheit roughly. Please click pause and don't forget to draw two good illustrations to demonstrate your knowledge of thermal energy.